Hi, I'm Chris from CD Lionel Trains. I've had a lot of questions about how to put together the Fastrack in a way that you can actually run a fairly complex layout. I've had significant trouble getting this to work, and I think most people have had problems with it. Now, looking on the Lionel sites and trying to read the books and as much information as I could get, they talk about a bus line, and we know what a bus line is, and that's the wire that runs underneath the layout, from which feeder lines run to individual parts of the track. But it's not as simple as that. There's different ways to do this, and I think what I started off was probably the wrong way. And let me just show you that on the paper here. So if you have your transformer, you need to have the two lines, the U and the A, and those need to go to the track, all right, together. Now when you have that, it goes around in different ways. You can actually have it go in a spider formation, meaning that you have your layout, which is say a single loop like that, and you can go from here, but then you can also connect it to here and to here and all the way around to the back like that. Now unfortunately, when you do it this way, you lose signal, and that's the problem that I've had, particularly with a complex layout with multiple train tracks running beside each other and in different layers. And so my friend Bob Camfield from Nevada showed me a better way to do it, and that's what I'm really going to describe in this video, is how to make that function. Now I'll show you what it should look like. If you have a track that goes in an oval, you actually want to have your wire follow it completely underneath or on the side, okay, just like that. And from there you want to bring up feeder lines, or your connections, in a 3 to 6 foot spacing. So this is between 3 and 6 feet between each connection. That's the first part of this. The reason to do that is because the ground wire is where you get your signal from, and when you have a signal that is being interfered with at multiple levels in more complex layouts, the trains will stop running. So I'm going to show you what I've done, and we're going to show you our layout, and we're going to show, well, some of the techniques that I've come up with to see if it's going to work or not. Now I've done this one on the first ring of loop, and it seems to be very successful, and I'm going to show you exactly step by step how to go through the next stages. First you're going to need, well, the wire. Now Lionel recommends 16 to 18 gauge wire. Now my friend Bob suggested 12 gauge, and I would agree with him. The higher amount of voltage that you can get through the wire, the less drop off that you can get. Now 12 gauge wire connected straight to the transformer, and then having feeder wires, they could probably be a lower gauge wire. You could probably do 18 gauge or 16 gauge and it would be fine. But because I don't want any drop off, I'm going to stick with the 12 gauge as feeder wires as well. Now the other thing I want to show you is the Fastrack. Now, is this a mistake or not to use Fastrack? Well, there are other options out there, and I think several of us are very frustrated with the fact that this tends to lose current. And the reason for that is, if you look underneath, is these connections. These pins that connect to each other have to be lined up with each other. See right there? And sometimes, because there's a space in between them, they can lose connection. And what we find is, if the track is not laid down securely, that you can have flexibility with that connection and it could drop off. Now the other thing that happens is, when the train runs over these connections, there is naturally going to be some fluctuation in the way the track moves, and that can interfere with the connection as well. So you're really relying on these connecting pins for both the power in the center and the signal on the outer rail. And if you turn the track over, what you find is that there's all these pins here, and this is a coming off of what Lionel said on their most recent video. These areas right here can be connected with wires, and they have to be soldered. And that's what Lionel does when they set up their demonstration tracks, is they don't rely on the pins, because the pins are not reliable. So I'll show you how I do the soldering and where we do it. The goal would be to do as many of these connections with individual wire between the tracks, so you're not relying on the pins, both for the signal and for the power. If you notice, for the Fastrack, there is a connection between both of the outer rails. And that's important. I think that that's very helpful. So that means we don't necessarily need to solder each outer rail to the black wire or to the ground wire, but we can do it on one. Okay, so that's going to be important. Now, if you want to go crazy, you can certainly solder both sides yourself. But this is an intensive process. Now, the goal is that we're going to have a track that functions, that the trains will run well, and that the power will not drop off. And so we'll go over some of those tips and tricks coming right up. All right, so we're going to show you how we've wired two different sets of the layout. The first part is the outer track, which is wired in the spider configuration. And I'm going to run the new RS3 Lackawanna, which is a beautiful train. But let's see how it works. Okay, first we're going to start up the track. So that's part of the problem here. We get to these areas where the power just cuts out, and I think it's really a signal problem because you measure it and the power is fine. So this happens routinely throughout the layout. If you don't have enough speed heading into these dead zones, the train will just stop. And so initially I've tried adding more feeder lines, and that just doesn't seem to do the job. And I think it's because what we've talked about, that the signal is being interrupted, and the train doesn't receive that, and so it just stops when that signal is interrupted. So now we're going to show you on the other part of the layout. So it's the track right next to it that has been wired using this other method, using the bus wire directly underneath the track, and I'll show you how that runs. Okay, now we're going to have the same train on one track over that has been wired with the bus line directly beneath the track. Again, that gives you the ground wire below the track, and it doesn't give any interruption in signal. We've also soldered the connections between the tracks, and we'll see how this runs. So this is at very low speed. It's responsive immediately to the commands. I'll give you the blowdown steam effect. Here you go. There's the blowdown steam effect again. We'll give you the water. And it is making the noise. And we'll give you a couple of commands.
Dispatcher, are we clear to the next milepost? Over. Yep, you have a clear track. Over.
Okay, now we're running at a very low speed.
We're on schedule. Out.
And that's excellent to be running at low speed without any difficulty. And we're going to pick it up a little bit to go to some of the other former trouble spots in the curve. And we're picking up the speed, and it's very immediately responsive. And I'm going to stop it right on the bridge here. And the bridge is always a problem because the wires are not connected under the bridge unless you run feeder liners. And I'll show you how we've done that later. But now we've stopped it on the bridge, and let me see if we can start it on a bridge. This was always a problem before. And it starts right up without any difficulty. And this is the curve we had difficulty with before. And I'm going to stop it there, and I'm going to start it back up. And again, very responsive. And we're going to go right around the track with this. Right back to the same spot. And what you'll see is the cars, the passenger cars, are all doing what they should be doing with the squealing and the noise. The lights are all on. There's no problems with any of the passenger cars either. So this is a successful wiring versus what we've had before. All right, so here is the next step that we have in terms of getting all the electrical connections together. There's different ways to connect wires in the bridge. These are some of the connectors that you have. These are the plastic ones, and these are the cheapest, and they're easy to cut into the numbers that you need. But there's not a lot of wires that you can fit through there, particularly if you have a higher gauge like a 12 gauge wire. They are easy to work with, and you can connect them right to any woodwork with those screw holes. The next ones are terminal connectors such as this, and these are a little bit stronger, a little bit more expensive. You cannot cut these, so you kind of get what you get. These are, they come in 2, 4, 6, and 8 varieties, and these you have to use a connector. These are the types of connectors that fit, and you clamp on the wire into that end, and then you screw it onto the terminal block with this end. You have the open ones like that, and you have the closed ones. The closed ones work just as well, except more difficult to remove when you want to change out any wires. If you should, you have to remove all the connectors on top of it to remove them rather than the bottom ones. And this one you can just slide in and slide out if you need to. Now, all these have some sort of cost associated, these being the cheapest without requiring these being more expensive, requiring connectors. Then I've also found these which are Ensure, IN-SHUR connectors, which are nice, except they don't work with the loose wire that we typically have on the end of the connections. These are the stranded wires, and these do not go through. These are designed for the solid copper wires. However, I have found a way to make them work, and that is by removing the insides, which you get this piece, which is a metal connector piece, and this is something that we can use to solder all of the pieces or all of the wires that you want to use during the bus connections, and then enclose it in this plastic container, and then wrap some electrical tape around this, and it works pretty well. And this is by far the cheapest option, as you can get a box of 100 of those for probably about $7, and you just require a soldering iron and some solder. So those are the options right now, and I'll show you what I'm doing with my first connection. So what I've done here, this is a section of the track which I've taken up, and you can see that there's a black wire that I've inserted into the foam, and this insulation foam is actually excellent to work with. You can shape it and cut it very easily, and here's a hole that I've put into the foam which will take the terminal block very easily. Okay, and I've done that with a Dremel device with a stop on it, and you can see when you look at the Dremel device and it has a stop, it goes down through the foam, and you can cut right through it very easily and take out a piece of the foam and remove it. And so that's the easiest way to do it. Just takes a few seconds. And so what I'll do is make these connections with the different wires. As you can see, I have a turn going off here, and because we'd like to keep the wires connected underneath and following every bit of track, what we're going to do is bring the wire up from the transformer and connect it into here, and then make multiple connections on this terminal block, one which will go forward throughout the rest of the track, the other which will go to the other side of the track down here, and the other which will go as a lead to the track itself. So we'll have multiple connections coming into this. So for this area, I've chosen to use the terminal block. So just to show you what I've done here is I've made some jumpers on the terminal block, and this will all be connected straight from the transformer. And you can see that there is a power and a ground here, and this jumps over to a power and a ground here, and a power and a ground here. And those can each be connected, so it gives you the ability to split the connections into multiple different areas. And so this will go to the side track, this one will go to the track above it, and this one will go to the track forward. Now I also will have a connection coming back, so you complete the loop with the loop that we've created, and it's going to come back and attach to here as well. And so that's how you make the terminal block work for you in this situation. So this is a good example of the difference between the wire thickness. This is the prior connection that I had, and this is an 18 gauge, and it's very thin. It's what's recommended by Lionel, but I just don't think it's adequate. Here is the 12 gauge, which you can see is a much thicker wire connection, and hopefully it will keep the current stronger with less drop off throughout the track cycle. Also, hopefully a better signal with the ground wire. And so I'm going to be cutting this old connection off, and we'll be replacing it with the soldered connection throughout. All right. All right, so here's an area that we want to get a bigger piece out of with the Dremel equipment. This is where we're going to put our connection that's going to go to the track. So this is going to be our center piece. Alright, and these can be pulled out just like that, and there they are. If you get a good look at that in there, you'll see that that's a nice big hole that was created, and that's where the connections are going to go. And it's pretty easy with the Dremel. And so this is just the wire, and it fits very nicely into that little hole that was created by the Dremel. And this can get right down in. I use a block, a rounded 2x4 piece, and you just going to put that in. And I typically put the black wire facing up because that is going to be where the signal comes from. Now, it probably is a little overkill to actually have to face it in that direction, but I'm figuring, you know, let's just make sure there's a good signal, and this should work just fine. And so if you see going over across, it goes in pretty quickly right into that hole that was created, a little trench. And again, we're going to go between 3 and 6 feet between every drop to the track, and that's going to hopefully keep the signal good, so we don't have to worry about it ever dropping out. So this is about where it's going to end up, and I'm going to just go back and run this along, and this will push that wire down, making it an even lower profile. I don't have to worry about the track ever getting close to it. Alright, and so that's it. So the wire is in place. It's inside the insulation board, and it's completely out of the way of the track. Alright. Alright, so now we're going to show you how to solder these things together. And first of all, I want to show you, if you have a good soldering iron, that will really make a difference. So this is one that we picked up, actually got it on Amazon. It's the Xtronic model 3020. And this is a lot better than the Radio Shack one that we had before. But I'll just show you, if you can get a picture right over here of the display. When you turn it on, this will tell you how hot it is. And you've got a temperature control right here that will get you that. And this is actually heating up as quickly as it's saying there. So you can get it heated very quickly up to over 800, 900 degrees, which is really nice for a soldering iron because you can turn it on and turn it off and it'll be ready to go. So that's incredibly helpful. So while that's warming up, okay, I'll show you how we prepare this little device, this Insure device that we have. Okay, so that's one of these. Again, remember you get 100 of these for about $7 versus about $5 for each of the other ones. So this is much more cost effective. And so what I do is I take this little poker device, grab some pliers, and hold on tight here. And then I just look in the center. There's a little hole there, and we can grab that, and we can try to just maneuver that thing out. And there it's coming. And there it goes. And so now it's out. Okay, so that's the piece you just throw away. And what you really want is what's on the inside, which is this metal piece. Okay, and so for each connection that you're going to make with the bus line drops to the track, you're going to want 2 of these. And so we have 2 of them. 2 pieces right there. And so for this, what I do is I get 2 pairs of pliers, and one to hold one side, and then you take the other one and you bend you look at the other one right here. You hold one side like that, and you take the other and you can bend these pieces back. Alright, and so that opens that up for you and allows you to get your wires in. Remember, they're the stranded wires, which otherwise wouldn't be able to go through these. But it allows you to have a place to connect to, which is excellent when you're creating your bus line drops. Again, there's lots of different ways to do this, and I'm sure there's other people who have much better ways of doing it than I do. But that's the way we're going to do it here. All right, so here we have the wire that's been stripped. These are all 12 gauge. This is the wire that's going to continue down the track. This is the wire that's going to drop to the track, and then there's the other wire up there that is the incoming from the power source. And so I'll just show you here with the video. Generally put one of these wires goes in here. Okay, and you can close that up. Alright, and then the second wire, these are all going to be the power. It goes in there. And we'll close that up. Okay, and then the third wire is going to be up here, right by the track. And that's going to be the red one. So you twist that a little bit. Okay, I'll put that all in there, and we'll just clamp it shut. Okay, right, and now we have our soldering iron. You're going to get that closer up to the track. Make sure there's enough. Okay, we have this on a platform that's going to give us a surface to work on. All right, and so typically what you want to do with the soldering iron show you right here, is you want to have your solder available. So what I'll just do is grab it, and there's nice hot soldering iron, and it goes right through it. Get a little bit of the flux, okay? And you want to tin these things, heating the metal. And you see it drops right in there very nicely. Alright, let's get another piece of solder here. Okay, and there you see that there's, put this back in here, there's the piece that's connected, and that's all three pieces connected at once, and that's really not going to go anywhere. Alright, and so what I do with that then is put the plastic cap on, and we'll get a piece of electrical tape. And we'll just secure that whole connection in here. And we get another piece and secure it up here. And there you go. You have a nice cheap way to put all the connections together, and it fits nicely and easy into that hole that we created. And I'll do the same for the other side, and then solder the wires to the track. Alright, So we're going to show you how to solder these wires, these connectors to the Fastrack. You've got the red that's going to go in the center, and then you've got the black that's going to go to the outside rail. And so what we've done is we've heated up our solder gun here, and I just want to get you to take a look at the tip of this. And the tip of the solder gun has to be, I guess, continue to be cleaned every time you take it out, okay? So the way you do that is you got to get a little flux put in there, and then you've got over here the coils. This is the copper coils, and you just got to continue to make sure that that's clean. All right, and then you want to tin it. You can see that right there. Put some tin on that, like that, and like that, and that'll work really well. So that's ready to go. We're going to put that in there and come back over here. And what I've been using is the flux and a little bit this little spatula tool, and you want to pre-tin your pieces. So a little bit like that, a little bit like that. This is with the flux, and then we're going to put some on each connector, right there, and a little bit right there, a little bit like that. And this will give you a good place for the solder to flow to. Alright, and so I take a small needle nose plier like this. Alright. See, it's very nicely soldered right there now. And these wires can just fit into that little notch. And typically what I do is put a little bit of electrical tape, little hole, connect it on there. Now, if the soldering is not done correctly, which is very easy to do actually, the connections can fall off, and with a lot of jostling from the trains, particularly over time, the connections will stop working and you won't have any power to your track and you'll get really frustrated. So trying to make these connections as good as possible and as redundant as possible will be important. Got some good extra connections there. So, you know, again, this is the best way to get some redundancy into what we're doing here, so that the power will continue to flow through the tracks, the signal will continue to flow through the tracks, and hopefully the trains will run well. Alright, so I'm going to show you guys how we get the wire under the bridge. So trying to keep the wire as close to the track as possible, and you're running a track like this, you actually want to attach the wire closely to the bottom of the bridge, so that the signal is connected as close as possible to the track. And so this is just what we've done here. We've done some hot gluing of the wires beneath it. I'm just going to show you how that works. So we've got a hot glue gun. This is from Woodland Scenics, and this won't melt the plastic, which is good. I'm just going to start up here, get some light, and just start with a little bit of the first part, and attach that right there. And as you see, it attaches pretty quickly. And we're going to move this wire slightly below the track, so it's going to come out a little bit. Some of these nice strings that come with the hot glue, but it's all right. And just using a piece of wood. You could use anything like a piece of a 2x4. We have a shim that we're using right now. And you just go and do this all the way along. Now, one other issue I want to show you is that when you have the feeder wires, one of the things I was doing is a extension off the bus line. You can see this wire right here coming off the bus line and connecting in the middle of the track. And I thought that this would work. I think the reality is that it messes up the signal, and I ended up taking out the wire on one side, and that seemed to correct a stoppage problem with the signal. And the same thing over here. I had an extension of a wire going from the terminal block, where underneath this track you have multiple different connections being made. One is going to the switch, one is going to the main line, and one is going straight forward. When I had a connection coming right here to add power, and another one coming from the terminal block going right underneath it, we kept getting a short. And I'm not quite sure why that occurred, but when I removed that wire, making the extension, it seemed to stop the problem. And what I did is I extended the bus line by just making a connection right from the track and the pins underneath, and continued it straight forward. And that seemed to solve that problem. And so that's one of the other issues you can run into when you're trying to get the wire correctly and continuing to have issues with shortages and signal loss, particularly with the complex layout. So now my job is to just continue to finish all of the wiring underneath all the track, and that should take me a while. But hopefully when I'm done with it, the trains will run perfectly without any stoppages, without any signal loss, without any shorts. Alright, so we're going to see how these trains run with the new wiring. We've got the first one, the RS3 Northern Lackawanna version, pulling the 21-inch passenger cars UP Frontier Excursion set with the Station Sounds Diner.
See you later, Dispatcher. We are
then right behind this, we'll have the Southern Pacific AC9 in the Fantasy Daylight Steam, holding 21-inch passenger cars from Southern Pacific.